Okay, so the theme for today is going to be given some information about a quadratic graph, finding the equation for it. Okay, and question
When did you guys get that?
last week or the week before?
Can I get that? Sorry.
Just for future reference, if you're gone for a while or anybody else is gone, if there's not an electronic copy up on school, like just email me and I'll put one up so that you have what you need. Okay. Okay. So anyway, given some information about a graph, a quadratic graph, we're going to try to find the equation. Okay. And the goal here, if we're given the vertex and any point, that we should be able to theoretically put it into vertex form. Okay? And so just by looking at this first example, here's your vertex, right? So the equation, working backwards, we don't know A, but what does this part have to be if the x-coordinate is 2? Yes?
0.
No. If the vertex is 2, what does this have to be in the formula? How would it have gotten there in the first place?
It's the opposite, so it's
X minus 2. Right. And now if the y-coordinate is 1, what does this have to be out here? 1. Okay? Does everybody follow where we're getting that from? Even if not initially, hopefully now you do. Okay? Once we have most of the equation written down, now we use the other point of the equation given to us. Yes?
So if it was like, if the vertex was 2 and -1, would it be that, but negative?
But minus 1 at the end.
Oh,
Yes,
okay.
exactly. Remember, on the inside, it shifts right or left, and it's always opposite. So if we're to the right 2, that'll be minus 2. And if the vertex is up 1, this on the outside matches whether it's up or down. Does that make sense?
Yeah.
Okay. All right, so then the only thing that we need to do now is just find A. And we can always use the other point that they give us to do that. We know x is 0 when y is 5. So if I plug 5 into A and replace x with 0, now it's just an equation that you can solve. Follow order of operations. First you're going to subtract and then square, right? What's this going to become right here? 4. 4a I heard, yes. So 4a plus 1. And I know you guys can solve that. What are the 2 steps left? Subtract 1 and then divide by 4. So a is going to be 1. So now you're going to rewrite your equation. It'll be y equals, and you could put the 1 out there. You don't need to, but you could write it out there. It's not wrong. Is going to be that. So this would be your answer in vertex form. Okay? Any questions on that? Okay, why don't you guys take a minute or two and work through example B, similar to the one we just did. Set up the vertex equation and then plug in the point to finish the problem. How'd we do?
Good.
Everybody get that one? Okay. Any questions? All right. Let's go through example 2. Okay, so now we have two separate functions, and we're just trying to graph and then just go through these list of questions that they give us based off of the graph. What does this graph look like?
Straight.
A straight line, yeah, it's just mx plus b, right? What's the slope? 1, and the y-intercept? Okay, so let's graph that. -3, and the slope is 1, so it'll go up and over 1. And I'm just going to, for the purposes of this graph, since I know the pattern really easily, I know this is silly, but I'm going to literally fill in every point so I have a very detailed graph. Okay. So F is going to be in blue. I'll graph. This is supposed to be g of x, by the way. G of x in red. This is just the regular parabola, but what does this -9 do?
So, or no, it shifts it right.
Shifts it down 9. If the -9 were in the parentheses like that, that would shift it right 9. So we're going to shift down 9 units. And now if you remember the pattern for the parent graph, you copy that, right? In other words, this is your 0, 0 point. Right here is your 1, 1 and your -1, 1 point. You know what I'm talking about? And then 2 goes up 4. And then 3 goes up 9. And so here is g of x. Okay, any questions on how I'm getting the graphs for either one of those functions? And look, worst case scenario, for this unit anyway, you'll have a calculator. Okay, this is a lot faster to do if you just know them, right? But if you have to put them into y1 and y2, get a table so that your graph is accurate, by all means you can do that. Okay? All right, part B, it says shade the region where f, that's the line, is greater than g, which that's the parabola, right? So from what point to what point is the line above the parabola? So from -2, you guys see that section he's talking about? From -2 to +3 in this section, ignoring everything else, right? So ignoring everything else, that's the part of the graph where the line is above the parabola. Does everybody understand that? Okay? That's all they want you to do for part B. Now they want us to solve this equation, f equals g. Well, f is x minus 3, and g is x squared minus 9. I'm going to do this both ways because it doesn't hurt to review, but we have the picture already, and we talked about finding intersections, I believe, on the calculator. We don't need the calculator, though. We can see the intersections, right? What are the x values where the line and the parabola are the same? -3, we have this point and that point. Did you mean -3? Yes, at -2 there's an intersection point, and then at +3 there's an intersection point. So -2 and 3 are the two solutions. Okay, you can either find those by looking at where your points of intersection are. So that's right there and right there. Look for the x values at those 2 points of intersection. Okay, if you don't like visuals and you're bad at graphs and you don't trust yourself with the graphs, you could solve this like usual. Set it equal to 0, right? Move things around. So now it's x squared minus x. And then add the 3 to the other side. So it becomes minus 6. And then this should factor easily to what? Yep. And if you set each one of these equal to 0, you get the same thing, right? So here's how to do it algebraically. However, the point of this is if you have a nice picture to go with it, you can save yourself the time if you know what to look for. Okay? The points of intersection were -2 and what was that? -5. And then this other point over here was 3, 0. Okay, we don't have much left. Are there any other questions? Okay, let's go on to the next page. Take 30 seconds and read example 3 so that you kind of understand the scenario there. All right, so we have a ball. I drew a baseball because that's the only ball I know how to draw. That was thrown up, and now they have a function here that models the situation. What does x represent? Second, so time. Let's do more specific. So time after ball is tossed. Okay, and what does this function spit out if I plug in time values? How many feet? How many feet it's... I know what you mean, but let's be more specific and say the height, right? So the height in feet. Okay. And now this was one of the things that you were supposed to kind of do at home, was to figure out how to find the vertex without completing the square. That's that weird thing that we did in class right before we had that, well, you guys had that 5-day break. Okay. How can I find the vertex quickly without doing all that algebra? Anybody? Yes. Very good. So the x-coordinate of the vertex is always negative b over 2a. So anytime we're trying to find the vertex for any quadratic, this is by far the fastest way to do it. Okay? If you plug in the opposite of b in this equation, that would be negative 64, 2, and then a is negative 16. This becomes a positive since their two negatives will cancel out. 64 divided by, what's this? So that's just 2. Okay? So after 2 seconds, so that's the x coordinate, right? After 2 seconds, how would I find the height now? What would I do with this 2? Yeah, plug it into x so I get that y value or the f of x value. So f of 2, and if you guys have calculators, you can help me out here because I don't have mine right here. So negative 16 times 2 squared plus 64 times 2 plus 100. Let's see. 164. So the vertex is at 2 and then 164. So now this question here just asks you to interpret, okay, so what does this vertex represent? It represents that after 2 seconds, the ball is 164 feet in the air. Does that make sense? Okay. You guys read example 4. I'll give you a minute or 2 to work through it, and we'll go over it, and then we're done. Quick section today. Still going to be part of the vertex because if you look at your variables, P represents the unit price, and that's going to be your x coordinate. When you plug that in, it's going to spit out. Okay. You see what I'm saying?
Yeah.
Part of what I've seen before from students in this unit that struggle is they get a word problem like this, and they're like, I don't know what to do. And actually, it's pretty much the same thing every single time. Okay? Up here, we had a quadratic. They gave us the formula. We wanted to know max height. So what did I do? Shortcut, found the vertex, used the vertex, answer the question. Does that make sense? Okay? Here, different model, different scenario, but this is still a quadratic equation. Does that make sense? And it still wants us to maximize or to find the max. Does that make sense? What other word could we see here that would still have us finding a vertex? So this one has maximize, right? What's the other scenario? Say that louder. Minimum, yeah. So if the parabola opens up, they might say to minimize whatever. Does that make sense? So if you see maximize or minimize, or maximum or minimum, and it's a quadratic equation, immediately you got to know we're just finding the vertex, regardless of how confusing a scenario it is. Does that make sense? It doesn't matter if it's time and feet or price and money. It doesn't make a difference. So, and actually, since we're using the shortcut, just so I make sure I don't make a mistake, this x, looking at the equation, is actually p. Does that make sense? And it's still going to be negative b over 2a. So did you guys start with that? Okay. Plug in, opposite of b is negative 40. And then negative 2 times a, that's also, oh, I screwed up. It's 2 times negative 2. So that should be 10. Did you guys get 10 for the revenue, or for the price? Okay. So the vertex is at 10. And now what do you do with this 10? Plug it in. So R, plug in 10 into R. Negative 2 times 10 squared plus 40 times 10. If I'm looking at this correctly, it should be $200, yes? So your vertex is at 10, 200. The unit price is the first coordinate, so that's $10 that they should charge. And the maximum revenue is going to be $200 for this situation. Okay. Any questions?